Right now, your finger is controlling millions of invisible electronic decisions. No buttons, no switches, just skin touching glass. But how does a flat screen instantly understand what you want? Your phone screen isn't alive. It can't see or feel. So how does it know exactly where you touched, how you swiped, or how many fingers you used? Why does your phone respond to your finger, even a banana, but ignore a normal glove? What looks like simple glass is actually one of the most advanced sensor systems ever made. A touchscreen is far more than just a display you look at. It is an intelligent input system designed to sense human interaction and instantly convert it into digital commands. Every tap, swipe, and pinch you make is detected, analyzed, and translated into data your device can understand in real time. Behind the glass, invisible sensors work continuously to recognize where and how you touch the screen. However, not all touchscreens function the same way. The exact process depends on the type of touchscreen technology being used, such as capacitive or resistive systems, each designed to interpret touch in its own unique manner. To understand who created this technology, we need to go back much further than smartphones. Touchscreen concepts were first developed in the 1960s by scientists working on radar and military systems. At the time, the technology was expensive, slow, and impractical for everyday use. It wasn't meant for people, it was meant for machines. Everything changed decades later when touchscreens became smaller, faster, and more accurate. The moment touchscreens truly entered everyday life was in 2007 when smartphones replaced physical buttons with smooth glass displays. From that point on, touch became the primary way humans interacted with technology. Phones, tablets, ATMs, car dashboards, and even medical equipment adopted the same idea of touch to control. But where does the touch actually happen? Surprisingly, not on the glass you see and feel. Beneath the surface lies a transparent layer packed with tiny electrical charges spread across the entire screen. This layer is invisible to your eyes, yet it forms an active network that never sleeps. Every part of the screen is constantly charged, waiting for even the smallest disturbance. When your finger approaches, it disrupts this electrical balance at a precise point, allowing the device to detect exactly where the touch occurs in real time. Most modern devices use what is called a capacitive touchscreen. This technology works by detecting changes in an electrical field. The human body naturally carries a small electrical charge. When your finger touches the screen, it disrupts the electrical balance at that specific point. Sensors immediately detect this change and send the information to the processor, which then determines the exact location of the touch. This entire process happens in just a few milliseconds, faster than the human eye can notice. The screen continuously monitors tiny changes in its electrical field and instantly detects exactly where the charge was disturbed, how strong that disturbance was, and whether one finger or multiple fingers touched the surface at the same time. Using this data, the device precisely understands the difference between a simple tap, a smooth swipe, or advanced touch controls used for zooming. The screen isn't guessing or reacting randomly. It is constantly calculating touch points, tracking movement, and translating your physical actions into accurate digital commands in real time. This also explains why gloves usually don't work. Most gloves block electrical conductivity, preventing your body's charge from interacting with the screen. No electrical disturbance means no touch detected. Touchscreen gloves solve this by allowing a small amount of conductivity to pass through the fabric. Before capacitive screens became common, many devices used resistive touchscreens. These relied on pressure rather than electricity. Two thin layers sat beneath the screen, and when you pressed hard enough, they touched each other, completing a circuit. That's why older devices required firm presses and worked with any object, including styluses. However, they were slower, less accurate, and couldn't support multi-touch.
Multi-touch became possible only when capacitive screens learned to detect multiple electrical changes simultaneously. This allowed gestures like pinch to zoom, two-finger scrolling, and advanced touch controls. The screen can now track several touch points at once, creating a smooth and natural interaction. So when did this technology truly change the world? The answer is the moment touchscreens became intuitive. Humans no longer had to learn machines. Machines adapted to human behavior. Touch eliminated barriers between humans and technology. There's no keyboard to memorize, no mouse to master. You simply touch and the device responds. This simplicity reshaped communication, productivity, entertainment, transportation, and even space exploration. The next time you tap your phone, remember this: you're not just touching glass, you're interacting with an invisible electrical system that reads your body in real time. Who created it? Scientists and engineers. Where does it work? Beneath the glass. When did it change everything? The smartphone era. How does it work? Electrical fields and human touch. Why does it matter? Because it changed how humans and machines understand each other. The future of technology isn't just something you look at anymore. It's something you touch. If this blew your mind, hit that like button and subscribe to InnoVision Tech, because next we'll reveal even more everyday technologies hiding unbelievable physics.